Hello dear students, today we are to see the mathematics for the class 8th. The first chapter of our mathematics is rational number and irrational number. So before starting the rational number, let's see some interesting part. If we spell the word mathematics, so we imagine the numbers and the operations on the numbers, that is addition, subtraction, division and multiplication. These whole things are carried with the operation of mathematical operation. We say that addition, subtraction, division and multiplication. Numbers are at the heart of the mathematics. So let's see, there are the number, whole number, integers. These are origin from the decimal systems. So let's discuss the decimal system. Decimal system, what is decimal system? There are 4 such types of system: decimal system, binary system, hexadecimal and octadecimal. But here we are to study only decimal, means we should know, because we are studying this following numbers, so we should know only decimal system. The decimal system is the system with the base 10. Base 10 elements or base 10 numbers. Base 10 numbers means what? Whole system is depend on the numbers 0, 1, 2 to 9. Means 0 including 1 to 9, these are 9 numbers, and including 0 means what? These 10 numbers, including these 10 numbers, whole the decimal system functions. We human beings interact with each other by using this decimal system, while the computer, electronic device, use the binary system, and whatever the command we are given to the computer or instructed to the computer is converted into the binary. The binary means what? It is the base 2 system, which includes only zeros and ones. We should not go in the deep to this system, just we should know. So we have discussed this system. So the decimal system carried out in the following numbers, such as natural number, whole number, integer. So let's see natural number. The counting number that start from 1, 2, 3 and so on are known as natural number, and the set of the natural number is denoted by the capital letter N. Set of natural number, that is 1, 2, 3, 4 and dot dot dot, that is so on, or simply we can give 3 dot for infinite numbers. And next is whole number. Natural number including 0 forms a whole number, and the whole number is denoted by capital W. So natural number are there with including 0 forms a whole number, that is 0, 1, 2, 3, 4 and dot dot dot, or simply we can say that so on, or infinite numbers. And next comes integers. Integers are what? Whole number including negative natural number forms a integers. Means first of all, whole number with negative natural number, and the set of the integer can be denoted by the capital I, or in some cases it is also represented by the Z. Most of the time we use I only, that is -3, -2, -1, 0, 1, 2, 3, 4 and so on. Here to represent the set of natural number, we use what? Whole number and natural number. To represent the set of whole number, we use natural number. Means these are dependent on one another. Okay, the smallest number is natural number, then one more number including 0 to the natural number forms a whole number, and whole number with negative natural number forms a set of integers. The next comes rational number. This we will see in deep. The number which is in the form of P upon Q, where P and Q are integers and Q is not equal to 0, means the number which are in the form of P upon Q, that is numerator upon denominator, where numerator and denominator are what? They are again the integers. It may be positive numbers, it may be negative numbers, or including 0, but one restriction is there, that denominator should not equal to 0. Here denominator is Q and Q should not equal to 0. If we take Q equal to 0, the number does not exist or they are undefined. So here restriction is given that Q should not equal to 0. The set of rational number is given by Q. Then the examples will be what? 1 upon 2, minus 3, 0, 14 upon 3, minus 19 upon 54, and so on. Here minus 3 will also come, because minus 3 can be represented by minus 3 upon 1. Again, then to show rational number on a number line. So first number is 7 upon 3. Now if such question is asked, or such things are, first of all what we have to do? We have to draw a number line. Here 0 at the center, minus 1, minus 2. Here plus 1, plus 2, and plus 3. 0 is the origin, or we can say center. To the right side of the 0 there are positive integers, to the left side of the 0 there are negative integers. And for your kind information, we can say that from the number line from the left to the right is in a ascending order, that is smallest, greatest, 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 and greatest, in this way. And from the right to the left it is in the descending order. It will use for when the comparison of the integers or the rational number is done. So at the denominator there is 3, means what? 7 upon 3. Here is what? Plus 7 upon 3, means it is a positive rational number. Positive rational number means what? It will lie to the right of the zeros, right side of the zeros. And the first thing is that the denominator 3 means what? The one unit after the 0 is divided into 3 equal parts, that is 0 to 1, this is 1 unit, it is divided into 3 equal parts. In the same way, each unit is divided into 3 equal parts. Now the denominator is 3, means what? 1 upon 3, 2 upon 3, and 3 upon 3, which is equal to what? 1. 4 upon 3, 5 upon 3, 6, 4 upon 3, 5 upon 3, 6 upon 3, which is equal to 2, 7 upon 3, 8 upon 3, and 9 upon 3 means what? Which is equal to 3. Now we have to represent the 7, means what? 7th point after the 0, from 0, that is 1, 2, 3, 4, 5, 6, 7, which comes 7 upon 3. Or simply we can write 7 upon 3 can be also given as 2 plus 1 upon 3, means here complete 2 units, 1 unit, second unit, and this 1/3 part, means what? Complete 2 unit and 1/3, means 2 plus 1 upon 3, or simply into mixed fraction we can say that 2 1 upon 3. Both the cases are right. The next is minus 2 upon 3. We have to plot negative number, that is negative rational number, that is minus 2 upon 3. Draw a number line 0, 1, 2, minus 1 is what? 3. So and it is in the negative. So left to the 0, each unit should be divided into 3 equal parts. 1, 1, 2, 3. Again in the same way 1, 2, 3. 1, 2, 3. Both sides you can do. Here it will be minus 1 upon 2, minus 1 upon 3, minus 2 upon 3 and minus 3 upon 3, which is equal to what? Minus 1. Again minus 4 upon 3, minus 5 upon 3, minus 6 upon 3, which is equal to what? Minus 2. Then what we have to plot here? Minus 2 upon 3. Then second point to the left side, it will be here minus 2 upon 3. It is very easy to plot the rational numbers on a number line. If such question is asked, plot 5 upon 4 on the number line, positive, means what? The one unit after the 0, or simply each unit after the 0 should be divided into, denominator is 4, so 4 equal parts. In this way we can plot a rational number on a number line. The next is comparison of the rational number comes with these 3 signs. So before starting to the point, first of all you will see, when the numerator of a rational number and the denominator of the rational number is multiplied by the same non-zero number, then the rational number does not change, it remains the same. For example, a upon b is a rational number. If we multiply the numerator and denominator of this rational number by the non-zero number, let k be any non-zero number. If we multiply by the numerator as well as the denominator, then whatever the rational number obtained by multiplying the non-zero number, it remains the same, where k should be not equal to 0. For example, 2 upon 3 is a rational number. If we take any non-zero number and multiply to the numerator and denominator, let it be as a 5, 2 into 5 and 3 into 5, that is 10 upon 50, that is it remains the same. So such type is known as equivalent fraction or equivalent rational number. Then for the comparison of the rational number, we will take 3 cases. First case is what? Both the rational number numbers are positive. Here one is positive and another is negative. Both are negative. Here both are negative. Both the now see, we will see this by examples. So first example is now here both the rational numbers are positive and we have to compare this both the rational numbers. So one thing we have to keep in mind that if the denominator of the rational number are same, we simply compare to the numerator. If denominators of the rational number are not same, then we will make it first of all same. So here is 4 and here is 3. So here nearest number, which number should be multiplied to the 4 such that, and which number should be multiplied to the 3, that such that both the denominators should be equal. So if we multiplied 5 upon 4 by 3, so we get, means here 5 upon 4 can be given as 15 upon 12 and 2 upon 3 can be given as 2 into 4 and 3 into 4, that is 8 upon 12. So if we compare this 15 upon 12 and 8 upon 12, which one is greater? Of course denominators are same, so we have to compare only numerator. Here 15 is greater than 8, so 15 upon 12 is greater than 8 upon 12, but 15 upon 12 is, which is equal to what? 5 upon 4. Therefore 5 upon 4 is greater than 2 upon 3. Next one, minus 7 upon 9 and 4 upon 5. Here minus 7 upon 9 is less than 4 upon 5, because negative number is always less than the positive number. And next is what? When both the rational numbers are negative, then see first of all, same method, we have to denominator should be equal, that is minus 7 upon 3 can be given as minus 7 upon 3 into 2, denominator also multiplied by 2, that is minus 14 upon 6. In the same way, minus 5 upon 2 is also multiplied by here we will multiply 3, because we have to bring the denominator as a same. It will be minus 15 upon 6. Now if we compare minus 14 upon 6 and minus 15 upon 6, which one is greater? Here both side it is a negative, so of course in the negative the smaller number is greatest, so minus 14 upon 6 is greater than minus 15 upon 6. Same way it can be given as, therefore minus 14 upon 6 stand for minus 7 upon 3, which is greater than minus 5 upon 2. The next is one example we will see. Here we have to compare this both rational number 3 upon 5 and 6 upon 10. So both the numbers are positive. If both the numbers are positive, then what we have to do? We have to first of all bring the denominator as in same, 3 upon 5. By what number we will multiply to the 5, that both the denominator will be same. Here if you multiply 5 to the 2, we will get here 10, and here already it is a 10. So only we have to find the equivalent fraction or equivalent rational number of this first rational number, that is 3 upon 5. So 3 multiplied by 2 divided by 5 multiplied by 2, which gives 6 upon 10. Therefore 6 upon 10 and 6 upon 10. This is the equivalent fraction of 3 upon 5. 6 upon 10 is the equivalent fraction of 3 upon 5. So we place in terms of 3 upon 5 as a 6 upon 10 and second rational number as a same. So both are equal. Means what we can say, that 3 upon 5 is equal to 6 upon 10. Then next, there are some useful rules. A upon B and C upon D are two rational numbers where B and D are positive, or simply we can say that they are greater than 0 or not equal to 0. Then again the comparison will be given into three cases. First of all, a upon b, c upon d are two rational numbers. So, if the comparison comes, we use this sign, a upon b equal to c upon d, and a upon b is greater than c upon d. Then if we do the cross multiplication, what we get? A multiplied by d is less than c multiplied by b. In the same way, a multiplied by d, which is equal to c multiplied by b. Again, a multiplied by d greater than c multiplied by b. C multiplied by b. Okay, good. So, in our textbook, it is given as, if a multiplied by d is less than c multiplied by b, then in the form of rational number, a upon b is less than c upon d. In the same way, if a into d is equal to c into b, then a upon b is equal to c upon d. In the same way, for the third one, if a into d greater than c into b, then a upon b is greater than c upon d. So, these are the three properties which can be again given in the two possible ways. We can again say that if a upon b is less than c upon d, then a into d is less than c into d. These both are same or supplementary to each other. In the same way, if a upon b equal to c upon d, then a into d equal to c into b. This is again supplementary to this downside. If a upon b is greater than c upon d, then a into d is greater than c into b. This is again supplementary to this property. In your textbook, this property is given in the form of this second one. You may use this also. These are vice versa. If the numerator of a rational number is divided by the denominator of the rational number, the structure we get is, or simply we can say that the whatever structure we get, that will be the decimal representation of the rational number. For example, if we divide 7 by 4, or simply take the rational number 7 upon 4. 7 upon 4 means what? If we divide it, 7 divided by 4 by as usual division method. So, what we get? 4 ones are 4, remainder is what? 3. Here 3 is less than 4. So, as per the rule, take here 0, give here decimal point. Now, 4 7s are 28. Remainder is what here? 2. Take 1 0. Here, once you take given here decimal point, and after number of times you may take zeros. No need to take again decimal point. Now, 4 in terms of 20, that is 4 5s are 20. Remainder is what? 0. Here remainder is 0 means what? The decimal expansion is terminating. That is equal to 1.75. Next is, again next example we will see. Minus 5 upon 3. If we divide, minus division comes. So, what we do? Generally 5 divided by 3. Whatever the question come, give it as a negative sign. Now, do as usual division. 3 ones are 3. Remainder is what? 2. Take 1 0. Again, if we take here 0, we have to give here decimal point. Now, 3 6 are 18. Remainder is what? 2. Take 1 0. Again 3 6 are 18. Remainder is what? 2. Take 1 0. Again 3 6 are 18. Remainder is what? 2. Take 1 0. It will carry it out. Okay. So, such type of decimal expansion are called non-terminating recurring, that is 1.666 dot dot dot, or simply we can give here same digit, that is 6 is recurring or repeating again and again, so we can denote it as 1.6 dot. Okay, this is a non-terminating recurring type of rational number. Then next example we will see 23 upon 99. 23 divided by 99. This is the rational number. We have to solve it or convert it into decimal form. Here 23 is less than 99, so the division can't possible. So what we do, if we take here 0, we have to give here decimal point. Now 99 2s are 198. Here remainder is what? 32. Take 1 0. Again 99 3s are 297. Remainder is what? 23. Take 1 0. 99 2s are 198. Remainder is what? 32. Take 1 0. 99 3s are 297. Remainder is what? 23. Take 1 0. Means from here it is again repeating. Here remainder is not equal to 0. Then quotient will also be recurring one, non-terminating recurring one. So if we denote it, the decimal representation of 23 divided by 99 is 0.232323 dot dot dot, which is equal to 0.23 bar. Similarly, the terminating decimal representation of the number 7 divided by 4, it was 1.75. This is the terminating rational number. If we have to denote or convert it into non-terminating recurring rational number, so what we have to do, we can add here number of zeros dot dot dot, which will give as 1.750 dot, which is non-terminating and recurring rational number.